Okay, looks like we're good. Got all forgot. I'll be quick. We'll try to fit in your coding challenge. I'll be quick with this. Cool. So my presentation nicely follows on from Chris's, I think. Chris was very much here's LabVIEW with non-NI hardware. Mine is very much here's some NI hardware with some integration with like LabVIEW FPGA, but primarily non-NI software. So that should hopefully actually fit in. It's quite nice. Quickly about me, I've been at NI since 2019, about 4 years, mostly during COVID. So the COVID years, essentially. As a shameless plug, I'm an aerospace and defense field application engineer. And the main reason I'm here is I don't live in the Midlands. I live in Manchester. The main reason I heard about this is I look after like Rolls-Royce as part of like my technical domain. And if anyone has any complaints, please direct them to Adam, who's sat there, who's the business contact for these things. But I deal with like a handful of aerospace defense government accounts, essentially. If anyone wants to chat about anything about this or just in general with NI, complain about things, there's my emails, just if you ever want them. As a quick side note, for people that do want to complain about NI, our website did get an update over the weekend. The documentation's almost usable. It's great. It's wonderful. So if people haven't checked it out since Sunday morning, you know, it's almost good. Almost. All right. Okay. Very quickly, what I actually want to cover. Essentially, so I have a CompactRIO set up over the desk for those people that are in the room. Make sure everyone knows what a CompactRIO is, essentially, what the actual 611313 standard is, the LabVIEW FPGA utility, a quick intro to CODESYS, and then essentially most of this is just going to be me having a demo of something super simple that works. Fingers crossed, because it's a demo. So, just before I start, if you have any questions, shout loudly and interrupt me, and that's fine. The CompactRIO platform consists of a few things. Primarily, it's this idea of like this packaged controller in the middle that you can see, and there's one right there. It runs its own operating system. It is its own device, essentially, and it has modular slots where you can say, hey, I want to add some digital input/output to this. You slot in a digital input/output, very similar to PLCs, essentially. There's board versions, but essentially it's the idea of, hey, we have this controller that runs LabVIEW Real-Time, runs LabVIEW FPGA, so you can program everything in LabVIEW with modular I/O, so you can make it fit whatever requirement you realistically have, so long as it's not something super niche where we'll point you to things like, hey, go use a Beckhoff motor drive. The operating system that runs on any modern CompactRIO, but I mean anything released in the past 10 years or so, is NI's like Linux RT distribution, which is open source. It's on GitHub. It's Yocto based, but essentially it's just a Linux distribution that has a load of the preempt RT patches applied to it, and then a load of the hooks that essentially allow it to be targeted within Macs and LabVIEW and all the other NI softwares that you might want to target it with. With the part where it's on Linux, you get the really fun part of anything that you build that can be like ran on Linux can be run on a CompactRIO within reason. I mean, it's an embedded controller. Please don't try to run like gigabytes worth of machine learning, because you will throttle it and it will die. Feel free to take all that data and put it somewhere reasonable. That's something we're happy for you to do. Just don't try to kill one by suffocation, essentially. And that includes things like the IEC 66113 standard of PLC programming things. But primarily CompactRIO, it's a real-time processor running on there, which allows you to do deterministic actions. There's an FPGA on there with a high-speed bus, and then you can shove in whatever modules you want, very similar to that lovely PLC you've got stuck there with a load of modules in. Cool. The IEC 6113 standard in general is the standard for PLCs that's existed for about 40 odd years at this point, I think. It's a vendor-independent standard, and specifically -3 is the standard for programming PLCs. So it defines basic software architectural languages of, ladder diagrams, block diagrams, structured text. The idea being that you can take this standard language and program this for PLC X, and it will run the same way on PLC Y and PLC Z, and you get the whole nice flexible way of doing things. Realistically, that doesn't always work out because the real world is nothing like that. But in theory, that's how it works until you get people that add on all the extra functions of, oh yeah, I'm just going to add in this little tweak to enable my thing, and then it becomes less reusable. But in theory, it's a great idea, like all standards. And like all standards, you get the lovely benefit of everything then is something that you can sort of trace back. You learn one thing and you can then track, oh, hey, I can now validate my software that's running on all these different platforms because it's all one standard thing. I can do the requirement checking, I can maintain it, I can do whatever I need, even if it's across different products, different platforms, different test beds. I can track it because I actually know one thing. That's the idea. The LabVIEW FPGA 6113 interface utility is essentially a way that takes an FPGA VI, so something that you've programmed in LabVIEW FPGA, created your bit file for, and you're running it on some NI FPGA target, and it translates that into a 6113 device description XML, which then maps all the inputs and outputs so that you can communicate with it through 6113 things like structured test or block diagrams. So essentially you end up with something lovely like this bottom picture where you have your FPGA VI, you've nicely compiled it, and I've already compiled it because I'm not going to make people sit through that. Create a bit file, go through your device description generator. You can run things through normal, typical LabVIEW Real-Time, LabVIEW FPGA, but in parallel, you can have a 6113 IDE that's actually running things and communicating with the CompactRIO target at the same time. I'm going to use CODESYS for this, mostly because it was the first one that came up that had a free license, and I was sort of proving this out to myself. CODESYS includes compilers to transform all the application code into actual machine code. Essentially, you just feed it device profile descriptions, and you program it in some 6113 standard, and you can then deploy things. Very quickly, why do you actually want to do this? It's mostly because I assume that most people that are here, given it's a LabVIEW user group, most of you know LabVIEW in some form. I think that's a fairly safe bet, and a lot of you might interacted with LabVIEW FPGA. Equally, I'm sure a load of you work with teams that don't know LabVIEW or don't have the skills to implement things like this, but might be more used to traditional PLCs. And I've worked at NI for a few years. I worked with NI stuff for a couple of years before that. There was quite a lot of crossover between where a PLC can be used and a CompactRIO can be used, just because functionally, if you're after embedded I/O or control algorithm systems, they fit the same purpose, just with different specifications and different flexibility. If you have a team worth of people that know PLC programming, but they need something more specialized, or you have something proved out, like you've done all your IVQ, VMV on a CompactRIO, and you then want to give that away and essentially not have the burden of you are the only person that knows how to maintain it because you're the only LabVIEW programmer or one of the only few, you can give this to people that know PLC programming, and they can just run with it and do whatever they need, prove it out, apply any essentially any already proven out software side from a PLC point of view to a CompactRIO, and you can essentially just wash your hands of that. They can go run with it, and you're free, and everyone's happy, which is great. Any questions on any of this before I jump into the demo? Great. Cool. Okay. I'm going to skip past some of the really boring parts. So here's a screenshot of Max. Here's a screenshot of Max being complete. And we're happy with that. No one cares about watching a Max progress bar go for a while. Right, let's go to the interesting part. Here is actually my LabVIEW. And I think someone asked earlier, does they don't have multiple LabVIEW versions installed on their host system? I have 4 installed on my host system and a stack of virtual machines, but I think it's cheating because I work at NI support. So I've kind of meant to do that. So this is my LabVIEW project. It is incredibly simple. I have an analog output card and an analog input card, and all of my FPGA VI is doing is I have a control that's going to the analog output, and I'm reading back from the analog input, and then wiring wise, I've just connected analog input 0 to analog input 0 and wired the grounds. So it's just a simple loop back, and then just an added bonus to prove that I'm not talking absolute, whatever you want to call it. I'm taking the temperature as well, so you can actually like convert that. So this is my FPGA VI, super simple. There are a whole 3 variables involved in this. But with this, if I compile it, which I already have, I can go over here, I can generate my XML device description. Say, hey, this is my source LabVIEW FPGA bit file, generate this, and generation succeeded. And this is the actual generation of the 611310 like device description XML that says, hey, these are the variables for like communicating with this target. This is what you're using. And for reference, that has appeared. This is where everyone gets really annoyed at me for how my Git structured. If I look at my LabVIEW FPGA bit files, here's the bit file I compiled a few days ago. Here's the device description I compiled a minute ago, essentially. From here, so now I've actually got this, I have something happening on my FPGA that super simple, but in reality could be your control algorithms, all your responses, whatever you actually need to do on your FPGA, whether it's data streaming, anything like that. I've just created, hey, this is how I actually communicate with this. And here's that actual XML. It's just a lot of identifiers of how do we actually do this. Moving into CODESYS. So I told you I can make this quick. I have a device already. So CODESYS, the way it works, there's a device repository full of device description XMLs that say, hey, this is how you talk to these devices, this is how you add them in. So if I have a quick look, I have my device repository. Under PLCs, I've added in the device description for general, like 64-bit, like x86 Linux and ARM Linux CompactRIO targets, because there's 2 architectures where we no longer do ARM Linux, but just in case anyone still has an ARM Linux target, it's still sort of supported in here. But we have a nice Linux CompactRIO, and this is that CompactRIO right there. I can go ahead, scan my network, and find this CompactRIO, which you all have to trust me that I have one network cable plugged in, and I'm not hiding more things under the desk. I can press OK, find that CompactRIO, and it says, hey, it is this. We are 01 bad 62E serial number. So I've actually found this in here. Past this point, if I go to Files and refresh it, I have a CODESYS. So the actual install of the utility onto the CompactRIO itself created a CODESYS folder, which I can just pop into, and it has exactly what you see within CODESYS as well. If I go navigate and find my bit file, and in this case, I'm adding the bit file, not the device description, but the actual bit file itself to CODESYS, because the device description is dealing with the conversion of that bit file to the 61133 standards. Copy it across, wonderful, and just a quick check. It is now one lovely bit file that's targeted on that, that's loaded onto my CompactRIO. From here, if I go add that FPGA, so within CODESYS, add a device, and then I was expecting a miscellaneous, unless I didn't actually add the device description, did I? Let me go install the device description as well. So one lovely device description that I made 3 minutes ago now. Install it, 09030 FPGA. and I can go ahead and add this device into my CODESYS project, and I now get my 9030 FPGA that is based from that device description XML that I just uploaded, that is based from the LabVIEW bit file that I can load and run within that CompactRIO controller. Everyone still with me? Cool. The internal I/O mapping of CODESYS lets me map anything contained within that device description XML to to variables within CODESYS. So I have one lovely PLC program, which I've nicely named PLC program, where all it's doing is I'm going to take in the raw temperature of the sensor that's on the CompactRIO that we configured, and then I've just dropped in the two variables of essentially like an input and the output, because I like cheating, and this is a nice way to cheat and just verify we have communication. I can force values and I don't have to actually program these. I then have a program that's just doing a conversion of raw temperature to Celsius, where it's just timesing it by 0.25 to convert between the fixed point representation of the temperature sensor to real temperature. Before I go over to my FPGA device, I can map this across. So my variable of 9263 input is input 9263. My 9221 output is my output 9221. And then my raw chassis temperature is going to be raw chassis temperature. I can go ahead, save that. And now I have the three variables that I've actually defined as inputs into CODESYS mapped to my FPGA device description. I can go log in here. It says doesn't exist. Do you want to create and proceed with download? Yes. I'll quickly build it. I can go ahead and start this, and you can see I'm immediately getting the temperature that's coming off my temperature sensor within that CompactRIO FPGA. And as well as that, I can go ahead and force a value, let's say 5, and force it across. And my 9221, the input module, is then actually reading that back within the loopback. So I've created an FPGA personality that's running on that embedded system that I can communicate through normal PLC, like ladder logic or structure test, however you want to do it. So in theory, if I had a complicated FPGA program that I need to run, or a complicated personality, or even something custom that I've created proprietary and even like hooked in things like some custom VHDL codes and IP integration that I've kind of brought in through clips, then all I have to actually define are my inputs and my outputs from the FPGA, which is just the LabVIEW controls and indicators, generate a device description that I can communicate through PLC logic. Running through this. We don't care about backup videos. Any questions? Probably make it quick. That gives you loads of time to do your code review.
Good stuff there.
Yeah. There we go.